Dzień dobry. Hello, everybody. It's good to be here again. So this talk will be a little bit philosophical as well, like what Nathan started off with. Fortunately, Nathan kind of set the groundwork to a lot of what I'm going to talk about. But I'm really going to focus more on, okay, if we can't have perfect software, what can we do and how can we evolve to make that better? Was anybody here a couple years ago when I was here and saw me talk? Anybody? Great. Okay. Because I have a little bit of stuff early on that's very similar to that, but since nobody's here, I won't have to worry about that. If a lot of people were here, I could skip that very quickly. But let me just kind of give a little bit of background about me, because I think that tells about the way I think, if you know a little bit about where I came from and where I grew up. So I actually evolved from the software architect group at the University of Illinois in the early 90s, and we were really committed on trying to make perfect software, or how do you have good architectures? Objects had the big promise, frameworks. This was even a little bit the pre-Java days, and then once Java started, we were part of that. Good patterns, how to get reuse, good component design. And lo and behold, we looked at a lot of stuff, and at the university environment, we noticed that although we talked a good game, a lot of stuff we started really looking at where people built these real systems weren't as successful as what we'd like them to be. And it's like, why is this? Why don't they have such a good structure? In fact, Brian Foote and I, we wrote a paper called The Selfish Class. And there I am, as a young guy in the early 90s, had lots of hair, a lot skinnier back then. And we really focused at that time. We did one of my favorite papers where we talked about, imagine you're a piece of software and you want to live. And so we took a philosophical view of what do you have to do to live? And we wrote this selfish class. We were motivated by Richard Dawkins on the selfish gene. Just like a piece of code, there's some different things that you can do in order to survive. And so we focused on this, and we really took a code's eye view. And there's a lot of things like it works out of the box. We see it with open source. If I grab something, is it easy to use? Can I get it up and running very quickly or not? Fold-out interfaces, so simple interfaces. Easy to it's easy to kind of understand. Good examples. We also had something like a gentle learning curve. So maybe it does more complex stuff, but the simple things I can get together quickly. And we even had something like low surface to volume ratio, like a sphere is equivalent in the physical world. But the same thing with our systems is maybe you get a lot of utility out of not too complex of an API. But lo and behold, one thing that Brian and I noted is sometimes software is reused. You might be writing on a winning team. So when Microsoft was doing very well, or you're on the Google platform and you get something with that, you'll keep surviving from that perspective. And sometimes things that aren't so good seem to survive. And maybe they're providing some kind of useful utility, but they can be very hard to kind of change and do something with. So this kind of motivated me and Brian to what we wrote about, believe it or not, about 15 years ago, the big ball of mud. And while much attention has been focused on high quality and what makes good software and good architectures, what happens to be, in fact, the de facto standard architecture, the most successful architectures, are these big balls of mud. We've all seen them, the spaghetti code jungle, entanglements, global variables everywhere, like a God class. And it was like, why is it that what we practice and what we preach is quite different? In fact, I was just in Brasilia, the capital city, a couple of weeks ago, and cities, and one of the analogies we used is like most cities, it's hard to completely design up front, just like with software. And we learned this a long time ago in the software industry, but lo and behold, some people still try to do it a lot. But even when you design it up front, like Washington, D.C. or Brasilia was an example that we used, which is the photo I have up there, is you try to design something all up front, but there's still, do we understand things right? Do we have enough understanding and really know what's going on? And in fact, being in Brasilia, it was kind of fun because we had mentioned it in our paper, and I had no idea I'd be there 15 years later after our paper and talking about this same topic. But even in Brasilia, I went to their national library, which is in the capital city, where they built this about 50 years ago. Brasilia was completely designed, and this is how the city is going to be. Their national libraries cannot even hold any books. And I was shocked. What do you mean it can't hold any books? Well, even though it was designed, it was a misunderstanding of the requirements, and the building was not built where it can have stacks of books. Now, fortunately, with e-books, they're starting to get some books in their national library in Brazil. But why is it that we have more of our software looks like those shanty towns rather than these nice designs like Frank Lloyd Wright, Mile High, that he wanted to build in Chicago, which never quite got realized? So a lot of times we have these architects or these people doing these pretty designs and trying to come up there and focus on why to do that, whereas in reality, it seems like most of our systems is we talk one game, but we end up with something not quite so good. So we've seen it many times. I mean, why did, I remember in the 90s, Macintosh had a clear, better Windows operating system than Windows, for example. But Windows really won during the 90s on that. And it seemed like there was some kind of quality that created that. And so part of it is this happens, and so maybe we need to look at why it happens, and maybe we can help make things better, and maybe strive for making the area that we live in much better. So one thing it's worth asking, where does mud come from? Well, we do it, right? Mud only comes from people who write code, ultimately. So people, lots of caffeine, lots of late nights, lots of merciless deadlines. And so a couple things that we talked about, I've never met anybody that went out there and said, I want to build an ugly architecture, an ugly system. In fact, a lot of times, some of these systems start out pretty elegant, very nice, but there's a lot of competing forces that once a system goes live, just like a city, once Brasilia went live, they had a lot of urban decay, same thing in Washington, D.C. It takes on a life of its own, and if you can't adapt and evolve the architecture with it, there's still lots of problems that can happen, similar to our software architecture. So, for example, there's some things like that'll cause it to tear up, some software tectonics, I'm calling it, such as merciless deadlines, going through evolution, piecemeal growth. But a lot of times, this is considered exactly a good thing. This is what we want to do when we're writing software, is evolve, and that's been a big thing about the Agile movement. So 3 of the biggest things that cause it: keep it working, that's usually considered a good thing; piecemeal growth, throw away code. We want to experiment with something and throw it away, but lo and behold, a lot of times, we never get a chance to throw it away, or refactor it, or clean it up. And here's another thing that can happen. Here's probably, even though objects had this big promise of reuse, I claim that probably most reuse is done through copy and paste. So you go out and find something that kind of does what you want, you copy it, put my name on it, take your name off, version 1.0, and then I start tweaking on it, but I don't completely understand it, and especially in large organizations, this can happen a lot, because you're the new guy on the block. You're the new kid in there, you got to come in and you're proving yourself. And they're like, okay, go add some new features to this legacy system, which is something you didn't write, or something that was written 2 months ago or 20 years ago or whatever. But it's a big system. Maybe the architect's not even around, or the original developers. They've gone to another company or moved on within the company. So here you have to work on something that you don't fully understand. But you want to look good to your boss, and you don't want to break anything. The company's kind of running its business on it. And so what do? Is you go copy something that kind of does that, and you start kind of tweaking it or hacking on it till you get it to work, and whoa, hey boss, it's working. The problem is you start getting lots of copies, and it can almost be like a cancer that happens in our code. And if we don't go back and clean things up, it can become a big ball of mud, ultimately. And so, I mean, this is still done a lot today. I recently did this. I don't know if anybody knows what RoundCube is. It's like a mail program, a web mail program, like Squirrel Mail. And I wanted some kind of new functionality. I grabbed a piece of PHP code that I didn't fully understand, built me a new plugin for it. I could kind of started understanding some things, but lo and behold, if I don't go back and clean things up, we can start ending up with a little bit of mess. So there's some outside forces that can lead to this, and in fact, a good example of that I know of is, like one of the biggest messes I've seen, well, Windows is well known for this. It's about 50 million lines of code for the Windows OS. But there's a well-known piece of software that probably all of you have used from a well-known Silicon Valley company, where they asked me to come in and look at how to refactor and clean this thing up, and they had a single C++ class that was well over 500,000 lines of code. Now, this is a very well-known Silicon Valley company called PayPal or something like that. And they've refactored it since then, and probably most of us have used that software, but this was so core to their business, people were afraid to touch it because so many transactions. And so how do you even clean something up like that? When they asked me, I said, very carefully, a bite at a time. Because, I mean, when you have something like that, and a lot of times one of the problems happens is you don't have good tests. And ultimately, let's look at where we're going. We're no longer living in the age where we can start with something elegant and nice and little. A lot of times we're under the gun to get something out quickly. And in fact, a Gartner report came out last year that in 2009, which I was really surprised, that email was far surpassed through social networking for communication. It's almost all, it's far exceeded that. And also with the cloud computing, which is about 40% of company resources now are going out on the cloud, and we're kind of mixing and matching and using other resources and plugging things together that maybe we didn't even write of it initially, and we're trying to create new apps and plug them together. And we're living in the app world. We're really moving much quicker with this. And in fact, Mosaic, which that round building there is where Mosaic, the first kind of modern web browser that was a GUI-based one, was done. That's really what Mark Andreessen did there at the University of Illinois before they went off into Netscape and things like that, is he took a lot of existing systems and used glue code to plug them together. So a lot of times when we're writing our systems, in order to meet the requirements and use a lot of existing systems that we may not even understand that well, we're kind of doing the age of sampling and gluing things together and making them work. But lo and behold, one of the reasons that I claim that we might have big balls of mud is just like physicists have learned recently. There's a lot of dark energy or dark matter out there. And in fact, they've realized that there's most of the universe they can't even see. So what they thought they knew, now they've seen that there's a big amount, 96% of the universe, that they can't even understand. Well, similarly, we're a very young industry. We're 60 years old, something like that, compared to people building bridges for a few thousand years. And so maybe there's a lot of things that we thought that we know now that we're going to learn in about 20 or 30 years from now that, wow, that object and cloud and closure and all these other ways of looking at things was just a wrong way of developing software, that there's potentially a lot of accidental complexity that leads to that. So maybe our current state of the art is just the best we can do. And as was pointed out earlier by Nathan, it's going to be hard. I mean, can we even get it perfect? It made a very good argument that there's a lot of good reasons why we can never get things perfect. So if we give this fact, maybe we need to accept that maybe muddy architectures are more normal than what we'd like them to be. It's almost like taking the first step for like somebody with a gambling problem. Until they admit they have a problem, they can't do anything about it. So maybe let's just admit that given what we have today, in spite of some of our best efforts, we're still going to get some mess and entanglements at times. And so maybe if we accept it and teach it, then we can make things more habitable. And also, I claim that there might be certain qualities to that. If mud is such a bad thing, why do we keep doing it? Right? I mean, if it keeps happening, too much software succeeds that has these problems. So lo and behold, I mean, in the early to mid-'90s, I was involved with all this, and then shortly after that, evolved from some of the object and the patterns community was the Agile. And a part of the Agile community was like, wow, our state of the art is terrible. How can we make things better? And so maybe some of these principles of Agile can help us prevent mud. Maybe make us deal with mud a lot better. And in fact, there's a lot of principles within Agile, when you look at it, that can help, such as we're going to have regular feedback. We're going to really empower the people to try to do the right thing. Probably one of the best things that came from the Agile community, which was part of refactoring before there was an Agile community, was testing was key. That was pointed out earlier. How do you really validate your software? Let's get some good tests, some good examples of validating that what we're building is correct. And we're going to really focus on learning and constantly making ourselves better. And so that's some good things to hopefully help us evolve. But lo and behold, there's some Agile principles that no matter what, that can still lead to mud. Oh, don't worry about the architecture. Oh, it'll just evolve. It'll magically appear. Don't even think about it, in fact. You're thinking too much. You know, imagine Kent Beck or Uncle Bob Martin kind of like, whoa, wait. Just focus on these requirements for the next few weeks on this sprint, and that's it. Take these user stories and go as quick as possible. So piecemeal growth, evolving the architecture. And then a lot of the process, we're going to do these stand-ups. And then working code is a measure of success, not quality code. Hey, it works. It passes the test. So, you know, quality on the outside doesn't necessarily mean quality on the good inside. And a good example is even remember when the iPhones first came out, they had this wow factor, certain qualities about the usability, and really had this early adoption, and people were all excited. But lo and behold, the battery life sucked and things like that. So some things on the inside were very difficult. You couldn't change the battery. So qualities are always about trade-offs. And in fact, it's been proven that there is this quality about being good enough. Does it meet the minimum requirements? Is it, at least, it's more correct than incorrect, as was stated earlier by Nathan. And in fact, as Nathan was talking about, we're not going to get perfection. I even take it a step further. I say perfection is the enemy of good enough. Trying to be perfect and make this software just the exact perfect software has caused many software projects to fail. So maybe in a sense, rather than having this quality where we're trying to quantify things, which in software is hard to do, what do you mean it's the software is this quality? It's easy to change? It's well designed? Well, that depends upon the people working on it and their experiences and where they come from. So they'll have a different view of it. And in fact, Gabriel wrote some of this stuff up back in 1991, which is really considered one of the first arguments towards open source about worse is better. It's really an argument to release early and get the feedback and evolve, and you got a community. And in fact, there's a certain quality in that. And in fact, this is from Brian Merrick's blog. He's a big guy in the testing world in the Agile community. And something that came up from Daniel Henson on this is the question that keeps getting asked is, what values does the customer get from paying back technical debt? Well, almost always, none from the customer's perspective. You know, and in fact, even Kent Beck in his book, if you read his book, he says, this book, so here's a book, Implementation Patterns, that's built on best practices on making quality Java code. It was written before Uncle Bob's clean code, Craftsman or all that. This was written a long time ago, about 10 years ago, about some of the best practices that you can do. And I'd highly recommend this book, by the way, Implementation Patterns, because it talks about some good things. And Kent Beck says this book is built on a fragile premise that good code matters. And like he said, and he's been out in the industry as well with a lot of people, he's seen too much ugly code make too much money to believe that the quality code is either necessary or sufficient. However, those of us that have to live there and deal with it, we know that it does make a difference, especially when we reach a point when we can't change the code so much anymore. So, in fact, a lot of these are patterns about how to make things better. So that's kind of, a lot of forces tend to lead you to getting these balls of mud and some ugly code. And so it's worth looking at how can we make things better. So part of this talk, as it was introduced, is how can we evolve to make things better? So I don't want to leave you with it just sucks, so we might as well just leave with it and keep it a mess. I mean, it's worth kind of asking ourselves is, are there some best practices and other things that can help us make things good enough from that perspective? So let's consider a code makeover. What can we do to make our code prettier? Are there ways to make it more attractive to programmers? Maybe we can buff up the code with lots of design patterns, refactor and test. It can become ripped with adapters, decorators, strategies, and the like. Just imagine our code with understandable, small, readable methods with clean, nice interfaces. and designs that have properties of high cohesion and low coupling, a place where developers are given the time and resources to make things right. Am I imagining too much? Who said software should be pretty? Does beautiful code mean that we have to have beautiful design? Maybe not, but those of us that have to live in the muck prefer something better. Just maybe, our perception of beauty or quality is distorted. You know? And as Richard Gabriel states, software needs to be habitable because it always has to change. So just like in my home, when I have to make things more habitable, there's always little messes, but maybe if we make it good enough so that it's livable, that's the main thing. So let's work on making our software where developers can feel at home and where we can make those changes. So yeah, there's going to be messes, but if we can contain it and evolve it. So maybe just like home software cannot always be pretty, but just because balls of mud are here doesn't mean we shouldn't try to make our code more livable. Now notice, if you notice that video, the person in there wasn't even real at the end. I thought she was very attractive to start off with. Before they did all the makeup and her hair, it's okay, I guess, but then that wasn't even good enough, right? So it's like we have this perception of what beauty is supposed to be that maybe we take it too far sometimes. And so maybe we have a false understanding of what is beautiful. And there is something beautiful about being good enough or just being who we are and going from that perspective. So given that, I want to take a little bit of time to talk about how we can refactor and sweep the mess under the rug. And so I want to spend part of this talk talking about how we can do a total code makeover if you have a ball of mud. Now, maybe some of you are living in places where things always stay clean, but I haven't been able to live in that place. So I've learned how to deal, what are some best practices that we can do? So if you have a ball of mud, you know, millions of lines of code. I mean, I was just talking to a large bank in Brazil, multiple million lines of stored procedures that's doing core business functions for calculating a lot of their financial calculations where a lot of their money goes. You know, that's quite a nightmare to be able to maintain and evolve this and add new types of financial products as they want to change the business rules on it. So how do you even start? How do you cordon off the mess if you've ended up with something like that and make it better? In fact, one thing that Brian and I mentioned, one of the first kind of steps towards that, is if you can separate things that change into different layers, those things can change independently without affecting other parts of the system. And in fact, we were motivated, if you look at, there's a really good book I'd recommend, Stewart Brand, How Buildings Learn, which makes good coffee table material, by the way, because it's got a lot of good pictures, cool pictures on it too. But even like this building, certain parts of it change more quickly than others. You don't want to be changing the plumbing every day. That would tear up the whole building or the site. Whereas some of the electrical and the other things that they have, or the walls, they have ways of separating the rooms real easily. So they've separated things out that need to change more quickly than other parts. Similarly, in our software systems, we have the same thing. Certain parts of our software systems will change more quickly than other parts. Ultimately, if something changes a lot, we can push it to data so we can really change it quickly. Now, of course, code is data too, you can claim, but then if we're able to even push it out to a database, these things can evolve very quickly. So if we have a ball of mud, one of the first things that we talk about, and even Michael Feathers talks about this, is about working effectively with legacy code, is you have a ways of wrapping up the mud so that the rest of the system stays clean. I've seen many examples of IBM doing this with their legacy systems. They'll put a nice interface on something. You know, when they had all these real old legacy systems that weren't object interface, they would sometimes give it a nice kind of object API interface. And then all the new code written at least goes to this nice interface, so you no longer have to deal with all the intricacies of what's going on inside and have a lot of entanglements and a lot of coupling. You just really are tied into that interface. And then what's behind it, you've kind of cordoned it off. And just like if I have a big mess at my home, a lot of times you're coming over to visit me and I have a big mess in my living room, I might take it into my bedroom and close the door so then I can deal with that mess later. And one nice thing is once you've cordoned it off, you potentially, through some adapters or decorators or other kind of wrapper patterns, you've set yourself up where you can start maybe dealing with the mud if it's changing. Now, it could be if the mud is there, but you don't need to extend it or change it, but you just need to use it, but then you could keep the rest of your system clean. That's fine. Don't refactor just to refactor to make it elegant. It's only as we need to evolve it. Though sometimes you need to do that. Now, another pattern that's not in our paper that Brian and I talked about is put a rug at the front door. So it could be that you have a component that is pretty clean, and there's a lot of other external services. Maybe you're selling services to different vendors, and you don't want to entangle your code with all the different types of varying ways that all these different services need to talk to yours. So then you can put a rug at the front door. And in fact, you can have ways of wiping your feet at the front door. You can have this protected system internally, these protected components, and then so they're coming from a lot of external services, and then we can have some different adapters or cleansing. Maybe you're doing some security checks or other things within these protected components, and these can stay clean, and we don't have to have a tight coupling with all these different types of things that may have different types of interfaces and stuff that have to talk to it. Now, of course, this, just like most mediators, can become a little bit ugly, but once again, you're containing it, and you're protecting your internal components that can stay much cleaner. In fact, me and Rebecca Wursbrock just wrote a paper off that, and anybody interested, email me. It'll be available at the ACM Digital Library soon, but it talks about patterns for sustaining architecture. So if your architecture needs to sustain and live a long time, there's some things you can do to protect that. And we also talked about paving over the wagon trail, which is another fun one. But if you're doing things regularly, just like in the old days when they were going out to the west, what did they do is they paved those over or made the railroads go through those same trails rather than trying to make it more easy to do those types of things. So refactoring is a technique that can help reverse some mud. And in fact, there's a lot of small steps that can take you a long ways towards getting that. And so let's go through some of those. Now, technically, our group, the group I worked with, they invented the term refactoring. They did the first PhDs in it, and they did the first commercial refactoring tools were done by some of those colleagues I showed you on one of the first slides. Don Robert and John Brantz. Don Roberts did a PhD with Bill Updike, did the first kind of groundbreaking with Ralph Johnson, the design patterns guy. And then they did the first commercial tools now that you see like in Java, Eclipse, and other types of languages as well. And technically, refactoring is behavior-preserving program transformations. Behavior-preserving. And you're like, wow, why would I change the code and just keep it exactly the same? Well, a lot of times when you're trying to add something new, sometimes it's hard to add something new because your code is so messed up and have entanglements that if you can somehow evolve the structure to something better, then it's easy to fix that bug or add that new feature. And so the main thing is if you try to add the new behavior while you're evolving it and something doesn't work, you don't know what you broke. So if you can somehow confirm that when you transform it to something better, you didn't break anything, that's good. And in fact, refactoring is a key and integral to most agile processes that you do out there that's become somewhat acceptable with that. And in fact, let's just look at a simple refactoring. A simple refactoring might be that we have a patient, we have like a doctor and a nurse. They're medical professionals, and they have a lot of similar type things. And so then based upon these similar types of abstractions, we want to get a little bit of, we don't want to have the duplicate code. So there's some maybe duplicate types of attributes and other things that we're keeping in this. So a simple refactoring is create an empty class, make these be a subclass of that. That's pretty straightforward. And then once you do that refactoring, the behavior shouldn't change. And at that point, then you can go where you can start moving up the common functions, some of the common types of attributes, and potentially get a little bit of reuse. Now that's not, that's not too groundbreaking, and it's usually a very safe refactoring. In fact, you can almost do this without tests, though a big part of refactoring was to have a lot of tests, which is, by the way, I really appreciated the point that Nathan made on that as well. But let's look at a more complex refactoring. Imagine you have matrices. Matrices are an array, is an array. So maybe we're inheriting from array for our matrices. And then all of a sudden we have to use these matrices on some small memory device. And we have a lot of identity type matrices and other things, and we have kind of a memory problem and performance issue. So we want to refactor that to something a lot better. So what we can do is evolve matrices to a different representation at that point, that they have an array representation. And so at this point, we're moving from is something to has something, which it's a lot of the design patterns, when you really looked at them, you get more reuse through composition rather than through inheritance. A couple are about inheritance, but ultimately, then we can have different types of representation. Now, obviously, when we go from inheritance to delegation, that's a much more complicated refactoring, because we're moving to kind of a different kind of strategy representation for what we want for our different types of matrices. So these can become very hard, but one thing is that's well known is you can take a lot of small steps to remove the bad smells and make things better as you go and evolve your design. Because originally, the inheritance was a reasonable design. But as our requirements changed and we grew, and all of a sudden we went from needing thousands of transactions a day to, wow, we're going to be like Twitter or Facebook or whatever, and we need, hundreds of millions or billions of transactions a day, we'll have to do that. But what's key for this is that every step, when we're taking a lot of these small steps, we want to make sure that we haven't broken anything else. And that's where a lot of good examples with tests can make a big difference. And in fact, testing is key. In fact, nothing I've seen over the last quite a few years has made a big difference, more important than testing. And so this is great that Nathan already set up the foundation for me, because that's exactly what I'm starting to see is one of the biggest things that the Agile community has done for us is really pushed the fact that we as developers and we as engineers is we need good examples to really validate that our systems work. And in fact, you must test. Just imagine if you had Uncle Bob there, that's part of the TDD or whatever, is testing is key. And so when you find smelly code, you're going to refactor, but if you're going to do this, imagine if you're going from one design to another design, how are you going to make sure that, with one big dangerous step, what broke? Whereas if we take a lot of these, we're doing move method, extract method, rename, we can go through a lot of steps and still validate things are good. Now, of course, if you're going to refactor and you want to make things better, it's important to know what is better. And this is somewhat relative to your team and the culture. But what I've done is, so Martin Fowler in his refactoring book, working with Kent and some other people, and including some of my colleagues, they put together, like, what are code smells? And he has a whole big catalog of different types of code smells and what leads up to them. What I did was put my top 10 list. So if you have a big ball of mud, you can make big gains on making things better by just taking a lot of these, dealing with this top 10, like sloppy layout, dead code, duplicate code, feature envy, whatever that is, inappropriate intimacy, long methods, large classes, like 500,000 lines in a class. That's pretty big. Thousands of lines and methods, 5,000 lines. A lot of switch statements. So how do we deal with some of this? So I just want to go through a few of these. Obviously, I can't go through all of these in this amount of time, but I will put a plug that during our panel tonight, our BOF, we're going to have a fishbowl where we want interactive. We want people from the other people to participate to talk about some of the best ways of evolving legacy code. But from my top 10 list, one of the things that I've seen is there's a lot of things that can take you real far, such as bad formatting, nothing and dead code. Nothing I hate worse than if there's a lot of different bad formatting, it's hard to read, and we got a lot of tools to help with that. And if you format differently than me and I'm on your team, every time you check code in, you might make it look like there's a lot of changes. And so I do diff when I bring it back in. I'm like, oh, what'd you change? Well, you changed one line, but because you put all the squiggly brackets on another line rather than the same line, we end up something like that. So fortunately, that's pretty easy to fix. And same way with lame names. By the way, I just want to take a second here. This is, if you haven't seen this code before, does anybody know what this does? This is a very famous, well-known algorithm that almost all computer scientists, anybody that's been at a university has seen, or I'm sure you've heard of. Does anybody Care to guess? How about now? Would anybody... I mean, just a simple thing is how we name things. In fact, a lot of Kent Beck's patterns in his implementation patterns is naming is key. And in fact, naming the what something does rather than the how, even how it's implemented is even more important, because then I can look at it and understand it and I don't have to get into all the details. So by just naming something like quicksort, you know, whereas if you use lame names, something that we all have heard about before and hopefully most of you know very well is by just kind of evolving a little bit, we can understand it a lot by just the way it's named. And fortunately, most of the tools take care of this. There's a lot of best practice patterns for doing this. If they're standards, you use them. Otherwise, there's some good ways of naming things, but I don't have time to go into all that. Now, duplicate code, we want to be able to, don't repeat yourself, right? So do everything once and exactly once. And so imagine if we have all these different types of ways of accessing the database spread throughout. Now we want to change the database, and now I have to go find all those copies and make sure I get it right and change the way that piece of code works. Whereas if we can isolate that, you know, and don't repeat yourself, the dry principle, is we can move things up into different components from doing that. Now, inappropriate intimacy, when we have a lot of coupling, or it's just like when I'm trying to reach inside to your privates. It's just like if somebody comes over to my house and you're a guest, I'll show you the bathroom, here's the refrigerator, make yourself at home. But it would be very inappropriate if you started going in the private part of my house and getting into my bedroom and opening up the drawers, and you know, that would be very wrong thing to do. And same way with a lot of times when you have private protected parts in there, it's also a problem if we're trying to deal with getting into those internals and doing things that we shouldn't be doing. And so therefore, if that class changes, that has a tendency to tear things apart. And same way with feature envy. If there's a tight coupling and every time I'm trying to do my work, I'm always having to pass and call, my function always calls over to you to do all the work because you have all the values and the extra methods that do on this other class. So one thing, a good refactoring is to move that method over to the other class. And similarly with switch statements, I'm not going to get into this too much, but a lot of the design patterns were about how to evolve from that. And in fact, Joshua Kiriosky has a very good refactoring to patterns book that if you're in Java in the object world, he has lots of good examples on going through to make your code clean. So there's a lot of steps that you can take to really make things better. But there's a time to do it. Regular refactorings makes it easier. It's just like if I'm going to a campground and I'm camping out. I should clean up my mess when I leave the campground. And in fact, if somebody else left a couple of cans there or whatever, what's wrong with me just grabbing and doing that as well? Similarly with code, if we constantly work on it, over time, believe it or not, these big balls of mud can start to be contained. You can take long methods, make them shorter, start breaking things down into some more reasonable pieces. And so there's some strategies. Refactor, maybe to understand or extend first, then clean up. Debug first, then clean up. Though sometimes it's easier to refactor first so I can extend and it takes less effort. So there's these trade-offs, and there's not like one best practice, but it's good to kind of think about this. Ultimately, and this is actually, when you really look at Fred Brooks, he talks about there's no silver bullets, but there's some promising attacks. And I think that refactoring can help address a lot of this and help us evolve. But it takes a constant attention to detail to really make this work. And in fact, Emerson Murphy-Hill talks about 2 refactoring types. And they have a lot of research they've looked out in industry. And Andrew Black, they put together a good paper, which I've got the reference, and I'll make obviously the slides are going to be made available. But there's really 2 different major types of refactorings. One is if we do it regularly, like flossing. The other is if, like what they call root canal refactorings. Now, I don't know about you, but I know which one of those I'd rather be able to do. If I take care of things regularly, it doesn't get quite so bad. There's a less chance of a root canal. It still might happen, but obviously we can minimize it. Whereas if we don't take care of things regularly in our software, we get so much technical debt where it can become a nightmare to even make any change or to evolve. And in fact, Martin Fowler even says this as well. So when we look at, that was a big part of Agile design values. When I put together kind of my list of Agile design values, continuous improvement, keeping the code better, evolving it, and even though we're not trying to make it perfect, it's good enough, but we need to make it more habitable, more livable. And the only way we're able to make sure we do things right is lots of testing, lots of validation, good examples from that. And in fact, there's a lot of Agile myths, which I won't go too much in here now, because I really want to talk about this, because I think one of the problems with that, a lot of Agile is we can just let the architecture magically evolve. Now, this is a great book. It's by Daniel Kahneman, Thinking Fast and Slow. I don't know if anybody has heard of this book before. A few people have. And the real cool thing here is it talks about there's a time for both. So example, if I'm out walking and all of a sudden I hear a horn, I instantly react and get out of the way so that I don't get run over. So fast thinking can be good, though sometimes it's good to stop, contemplate, make sure I'm building the right thing. And fast thinking, a lot of times with the Agile practices, Scrum, TDD, just the next sprint, only focus on this. Red, green, red, green, red, green on your test. Go fast, you know. And so we get caught up in this, and we might be optimizing, micro-optimizing just within this space. But sometimes it's important to do a little bit of slow thinking. And it's important to take time for both. Slow thinking might be pairing, noodling, do some spike solution. It's just like I believe in a more pragmatic test-driven development. You don't always have to write your test first. It's okay if you do. I'm not against it. Sometimes, though, you might want to go experiment and try some things, but then have good examples for validating it. And in fact, Scott Ambler, in the original test-driven development discussion from a long time ago, he put together that really most people miss this iteration 0 on TDD, which is envisioning. Are we even building the right thing for our company? You should take a little bit of time and think about that. What is the main architecture that we need to think about? The main thing is he calls it conceptual modeling. We don't want to do too much of it. And then you get into but it could go on for days, weeks, or months just to make sure. I mean, this is going to be a multi-million project. It's going to run $1 billion company for many years. We should really think about, what are we really building here? We don't want to just go build the wrong thing. And then once we get into it, we can get into the fast cycle. But even in the fast cycle, you can still do a little bit of modeling in there. And in fact, what I like to talk about it, one person earlier asked a question at the end of Nathan's talk, is that bug-driven design? I think it's example-driven design. We learn things better as we evolve and get more example. We really validate that we feel more comfortable that this does work most of the time. And if we have more examples and good examples and within our software, we can kind of validate that, and those examples make for good tests. And there are some other techniques Steve McConnell talks about. Testing is not enough, but testing is a big important part of that. So can tools help? Well, clearly yes. Refactoring, Lint, code critics, let's find code smells, let's do some refactoring. That makes a big difference. But they're not a silver bullet. So we can escape from the spaghetti jungle. We can make things better. If you have a big ball of mud, a lot of small steps, which I've outlined a few of them, you can make strides towards getting to the end. Now, as Fred Brooks says, there's no silver bullets, but I'd like to believe that there's a lot of promising attacks. Testing, refactoring, pay attention to detail, good people, empower those people to do the right things. And it's still okay to think about architecture, even if you're being agile. It's okay to have agile architecture. I saw there's a couple talks here about that. And I would highly recommend anybody that has not read this book, The Mythical Man book. It's a classic. It's just great to read. So mud is here. I'm not saying that it's not. It isn't always bad, but it can be contained. And we can at least make our code more livable, habitable. So there's some hope. But maybe mud is why we have Agile. It gives us Agile is the best way to deal with this. And having a lot of these testing and examples is we can get software that's good enough and we can validate and feel more comfortable about. So I say be more pragmatic rather than bullheaded. Be more practical. I'd rather be like the little puppy than the bulldog. So anyway, I want to just end with this. I think I love the Agile mindset, but the Agile mindset isn't being rigid in what you're doing. It's being more practical. Do what yields the most values. Find the right set of tests that give you the most value. So it isn't like do Agile, be Agile. So once you're kind of being Agile, it's just like you're just kind of moving along. When you're Agile, you're really able to adapt and move to changing things. So it takes a village. I started out with those guys, but obviously there's a lot of other people that have influenced me over the years, like Fred Brooks, Dave Parnas, Ralph Johnson, Dave Thomas, Kent Beck, Linda Rising, Ward Cunningham, all these other, Richard Gabriel, Rebecca Wursbrock over there. And of course, one of the organizers here for asking me to come. So anyway, that's really all I have. Last time I got to see those two guys, Fred Brooks and Dave Parnas, when we had a really fun, No Silver Bullet Revisited panel, where Martin Fowler put on a wolf mask. It was awesome. You can go to YouTube and check it out. It's pretty cool. So anyway, that's what I have, and maybe I have time for a couple quick questions.
Unfortunately, thank you very much for the presentation. We run out of time.